What is physics? Physics is the science of how natural phenomena occur in the universe, by studying matter, energy, and their interactions through experiments, measurement, and mathematical analysis. We can understand it better by classifying it under two branches, that is, classical physics and modern physics. Let's overview the classical physics. This branch comprises the scientific advancements and physical theories developed between 1600 to 1900. Mechanics, thermodynamics, electromagnetism, optics, and acoustics are the primary realms developed during this period. Mechanics. The science of why and how things move evolved mainly under British physicist Sir Isaac Newton, who proposed the laws of motion and the universal law of gravitation. Thus, mechanics is also referred to as Newtonian mechanics. Thermodynamics. The science of transfer and exchange of heat, developed mostly under Joule, Clausius, Boltzmann, and other such eminent physicists. Electromagnetism. The science of the interplay between electricity and magnetism was best studied by the likes of Maxwell, Faraday, and Hertz. Optics and acoustics are the two other realms that highly progressed during that period. While Newton was the pioneer in the field of optics, Christian Huygens further enlightened us about the nature and behavior of light. Let's now overview the modern physics. In the 20th century, several phenomena were discovered that classical physics failed to explain, and our understanding of the physics of the universe was challenged, yet again. New theories such as special relativity and quantum mechanics emerged during this period. Quantum mechanics. It is the hazy science of particles of the subatomic realm, and how they notoriously change their behavior just by mere observation. It quantized energy in the form of discrete packets, called quanta, and deals with the probabilistic or statistical calculation of these particles. Relativistic mechanics is based on the theory of special relativity and general relativity, both proposed by the most famous physicist of our time, Albert Einstein. These theories provided a whole new understanding of how the universe works. For the sake of our curriculum, we will only study the classical physics and the basics of modern physics. Evolution of physics. In comparison to other sciences, such as mathematics, chemistry, biology, and other natural sciences, physics holds an integral place, as it enables us to answer the most important aspect, that is, why and how. And thus advancements in physics lead to new technologies and vice versa. This has been a common trend in the past few centuries. For example, the laws of thermodynamics led to the invention of steam engine, Newton's laws of motions led to advancement in rocket propulsion, and the electromagnetic theory gave us the particle accelerators. Fundamental forces of nature. For a true understanding of our physical world, we need a proper understanding of how different particles interact fundamentally, under different conditions. To identify such fundamental interactions or forces, scientists use two major approaches. That is, unification and reduction. Currently, scientists have identified four fundamental forces of nature. These are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. The gravitational force. Discovered by Sir Isaac Newton, it is the weakest fundamental force that revolves around the central idea that matter attracts every other matter. It is also responsible for keeping the things held together in space. It is a long-range force. The electromagnetic force. Also a long-range force, it is the second strongest fundamental force that acts on the charged particles. It is responsible for many daily phenomena such as electricity, communication, and even our ability to touch different things, since we are as made of matter as well, and matter consists of charged particles. Strong nuclear force. 137 times stronger than the electromagnetic force. The strong nuclear force is the strongest fundamental force. It is responsible for holding the nucleus of an atom together, and is a short-range attractive force. Weak nuclear force. Weaker than the strong nuclear force, is it also a short-range force. It is responsible for radioactive and such other nuclear forces. However, scientists still await the day when the quest for the grand unification theory will be over. Such a theory will theoretically be able to explain all the naturally occurring phenomena. Two pieces of this jigsaw have already been put together, as the electromagnetic force and the weak nuclear force have been unified. Scientists all over the world are in a constant struggle to put together the remaining pieces as well. Now you can visit EduRev and find other such exciting videos, documents, and practice online tests to check your understanding of this topic.